This video is about linear regression, and this is the last topic for the course. It's a way of trying to predict something that might come in the near future. Let me start with an example here. We have some data that shows a relationship between the heights of buildings and how many stories the buildings had. So what I'm going to do is label this first one X and the second one Y. Then what I'm going to do is graph them. X will go along the horizontal axis and Y will go along the vertical axis. I don't need this to be a great picture. I just need to get the idea across. So the X's, as you can see, they go anywhere from 501 to 1136. So I'm going to start it at 500 and just count from there every 600. That covers the X's. Now the Y's go from a low of 39 all the way to a high of 83. So I might start it as low as 40. Let's see, 50, 60, 70, 80, and that should be enough. So let me put my 80 up here, and you can label as much of it as you want. And what I'm going to do is plot these values. So looking at this first one here, height versus stories, I'm going to go, now this is not going to be exact by any stretch. I'm going to try to figure around about 1136 on the x-axis, and then I'm going to try to go to a height of what I think is about 83. So follow along with my cursor here. Right about there is I'm estimating about a 1136, and then I'm going to go straight up, and I'm going to put a dot right about here. That's my estimate. Now I'll move on to the next one. When X is 887, we get a Y of 76. So 887 is a little before 900, and 76 will be a little more than halfway in that band. So I'm putting it right about here. Next, 756 and 50. That's almost exactly halfway between 700 and 800, and 50 is right here. Then we have 668 and 49. 668 is a little more than halfway from 600 to 700, and 49 is right below the line. So I'll put it right here, let's say. And then 595 and 54. 595 is almost 600. 54 is a little less than halfway. So I'll put a dot there. And then finally, 501 and 39. So that's going to go right about here. Now, what we want to do here is we want to try to come up with a line that sort of models this data. You can see the data kind of lines up. Well, we want to create a line that runs through the data, and then I can use it to predict something. Say, for example, if I am able to come up with a line, an equation for a line that this data tends to, then I might be able to throw in something like 85 stories for X, and it will spit out the most probable number that it could be based on this data. So we look for a certain line that goes through it. I don't know what it is right now, but I'll show you just an idea. Let's see, get my shapes. Here we are. I don't exactly know how it's going to be, but it's going to come through something like this. And so the way to get, what I'm going to do is get the equation of that line that I just drew, and that's where you need Desmos. So let me come to Desmos. You can do these with any statistical calculator as well. Let me put in some data. I'm going to delete this table so that you can see it from scratch. Remember, to get this started, you just type in table and it will automatically make one up. Let me put in the numbers. 1136, it'd probably be easier if I did it this way. And maybe make this one small as well so that I can see them both at the same time. There we go. I'm going to enter all the x values first. And now I'll put in the y values. I've got my data. Now, you can see the graph of all this stuff, but you have to size up the thing appropriately. Like, for example, I need to do like I did for my x and y, I need to do it in here as well. And you can do that by specifying it here at x-axis. I would prefer my x-axis to go from like 500 to 1200. And my y-axis, I want it to go from 40 to 90. And let's take a look at the data. So there's the data. It is a little off from being perfect in there, but now if I type y1 and then I type I don't know what you call that thing, the squiggle button. It's next to 1 on the keyboard. It's the one with the little prime mark and a twiddle. I guess it's a twiddle. Let's call it that. But if you simply type in mx1 plus b, it gives you all that. You can see here's my m in here, and you can see the b. So let me grab all of that stuff, and I'm going to bring it into our work area. Okay, so the b is a little more than 5. It looks that, so this line doesn't look too bad. So let me write the equation of this line up here then. We have y equals, the m is found down here. I'm only going to do 2 decimal places for these. So my m is going to be 0.07. Put your x and then put the b. The b here, I'm only going to do 2 decimal places for that as well. 5.74. That's the equation that you're going to do your predictions with. So let me write these down then. So the linear equation line is this: y equals 0.07x plus 5.74. Not only that, they give another number in here too. This guy right here. We'll talk about that in a minute. But that R is called the goodness of fit. And we'll talk about its purpose after I finish this problem. Predict. The height I already said the wrong thing. Let's try this again. Predict the number of stories for a building that is 1,200 feet tall. And the way you do that is you take your equation and you put the 1,200 in where x was, and then you add the 5.74. Just to remind you of some words that were used, the 0.07 was referred to as the slope. The 5.74 is called the y-intercept. But anyways, this is going to give me a number that I'm going to say is the number of stories. So let's pull out the calculator. I ended up getting 89.74. Remember, that's just an estimate, so we're talking probably somewhere around 90 or 89. But that's all we're looking to do in this with these problems. Get me an equation, tell me how good the fit was. That's the part I'm going to look at over here. This guy right here, R, I get 0.9274. When that number is close to 1, like 0.9 to 1, we're going to get a pretty good fit like you do in this line. It fits the data well, and it manages to minimize the errors of such a line. When this number is close to 1, the fit is good. When the numbers are close to -1, the fit is also good as well. Let me show you. Here's another one, and it lists the number of absences plus the final grade. So it's looking for some sort of a correlation between the two of those. So once again, I'm going to draw just a rough sketch. It doesn't have to be good. I just want to see if the dots kind of line up. So when I look at my x-axis, that's this one here, the values go anywhere from 2 up to 15. So maybe I'll go by 2s. Oh, my 15 may be out of place, but I'll go ahead and put it as a 16 then. Now the y values, they go from a low of 43 to a high of 90. So maybe I'll start it at 40, 50, 60, 70, 80. Up, I got to go one more. 90 is up there. It's going to interfere with my graph. And let's start graphing here. So when x is 6, y is about 82. So I'm going to 6, and then 80 is here. So 6 go up to 80, a little over 80 to 82 maybe. All right, and then when x is 2, y is 86. So it's going from 2, I'm going to go a little more than halfway between 80 and 90. And then what's next? 15, 43. So that's in between. I'm putting it right about here. And then 9 and 74. So 9 is halfway between 8 and 10. 74 is a little bit less than halfway between 70 and 80. I make that dot bigger. Then we have 12, 58. So 12 is right here. Move up to, there's 50 and almost to the next level. Dot. 5 and 90. 5 is midway between those two, and it goes to the highest level. Put it right about there. And then finally 8 and 78. 8 and 78. You can see for a lot of it, it is almost a straight line, but then you've got this weird thing there. So whatever it's going to draw, let me see if I can approximate the look of it with a line. We'll grab this line here. So it's probably going to do something like this. And you can see it's going downward this time. Last time it was what we call was increasing. This time it looks like it's decreasing. So let's put these numbers in to the calculator, well, Desmos. And let me see if I can make Desmos small enough so I can see these values. That'll be good enough. Make this bigger so I can see what I'm doing here. Like before, I'll do the x's first. 6, 2, 15, 9, 12, 5, 8. And let's go up to the y values. 82, 86, 43, 74, 58, 90, and 78. Now that I got the data in, I'll go back to Desmos altogether. Now the numbers have changed here this time. And let me get, oh, look at these. Don't forget to delete the rest of the stuff. I don't know if I can do it. I probably got to do it this way. I don't know if you can hit delete through these things. Okay, let me get my thing. I'm going to do like I did before. I'm going to go from 0 to 15. I'm going to go from 0 to 16, I think, for the x's. So the x-axis will go from 0 to 16. And I think it's got the y-axis must go from, what I say, 40 to 90. And then it is, or it's already doing that. So you can see the data is like we had before. And when I drew it up, and here's the line that's going through it. Now, I'm not going to bother with the data anymore, but I'm going to grab this stuff here. Here, R equals negative 0.9442. And you can see the graph is tending downwards. That's why there's a negative in front of this. You might remember from your graphing days that that meant the slope was negative. And our equation here is y equals negative 3.6. I'm going to go one decimal place here, plus 102.5. And then we could say predict the grade at 17 absences. Well, we take y equals negative 3.6 times 17 plus 102.5, and that will be your prediction. I end up with 41.3. It kind of makes sense, though, that the more days you miss, the worse you're going to do in a class. Here is one investigating a relationship between average wind speed and maximum wind speed. So here's our data. Let me draw a rough sketch of it. Now, I'm not going to require you to sketch these graphs. I'm just doing this for illustration purposes. Let's see, the x values, we'll start them. We'll use these for the x values. So the lowest value here is 6.1, and it goes to a maximum of 11.5. So maybe we can go from 6 to 12, 6, 7, 8, 9, 10, 11, 12. And the y values have a low of 68 and a high of 83. So I could probably go like this. I could probably go 65, 70, 75, 80, 85. Finding a good scale is very useful at the beginning. Now, when you graph, it doesn't have to be exact. We just want an idea of the shape. So my first point is x equals 8.2, but y equals 83. So 8.2 is between 8 and 9, but close to 8. And then I'm going to go straight up to a little under 85. Next, we have 6.2 and 72. So that's a little beyond 6 and a little beyond 70. So I'm going to put the dot right about here. And then 11.5 and 76, halfway between 11.5 and just slightly over 75 here. 9.6, 68, so somewhere midway between 9 and 10 and 68. $10 and 74. $7.4 and 70. And 6.1 and 72. That's close. 6.2 and 72 and 6.1 and 72. Interesting. They'll be right next to each other. But what you see here is there's no real rhyme or reason to this shape. Let's throw it in Desmos and see what that R value is. So once again, for the moment, let me make this small so that I can edit it inside of here. I'll put the X values again, 8.2, 6.2, 11.5, 9.6, 10, 7.4, 6.1. Oh, I see. What it does is it doesn't delete the data. It won't let me select more than one cell at a time. All right, let me get my other numbers in. 83, 72, 76, 68, 74, 70, 72. Now let me come in here into Desmos. And I see that I should probably delete this table and start over again, but they've adjusted some things here. But I want you to see now, they've got a line through it, that's for sure, but look at this. Let me grab this and bring it over into our work area. Here, look at this R value. It's now not close to 1 or -1. This is bad correlation. So let me reiterate these remarks. What I'm talking about is something called the coefficient of correlation. And that's the guy we've been calling R. R will always go between -1 and 1. No matter what, it's going to be between those values. And here's what's going to happen at various stages. If you see a bunch of data lining up like this and in an increasing fashion, you can bet that this R is approximately +1. So this would would be called a positive correlation. And then likewise, if you see it going something like this, pretty much lined up, this R is close to -1, and this is negative correlation. Both of these are good. On the other hand, if you've got a graph that has no rhyme or reason to it, things are just all over the place, like this maybe, then the R is going to be closer to 0, and there's no correlation. Obviously, if we have no correlation, we're not going to bother with using it to predict anything. It's worthless. Here we have data shows the final exam grades for 16 randomly selected students taking both college algebra and statistics. Use the college algebra scores for the independent variable. That means we're going to be calling it x, and the statistics scores then will be the dependent variable y. So remember, independent is x, dependent is y. Well, the first thing we're going to need to do is get this stuff into Desmos to calculate some numbers. Now, if I just down arrow, I think I can overwrite the old stuff. So there's 97. I'm doing the x's first. 73, 92, 81, 79, 71, 90, 86, 58, 87, 68, 74, 86, 62, and 95. Now let me get my y values in. 86, 95, 78, 97, 87, 81, 75, 85, 90, 70, 85, 77, 76, 81, 65, 89. And it has a new model up here for us. Our R value is pretty good. So this is good positive correlation. Our Y value, Y equals, I'm going to go one decimal place, so I'm going to go 0.7x plus 26.7. So then let's make a guess. The college algebra were the x values, and the statistics were the y values. So let's pick an x value. Let's see, the highest score for x was a 90. Let's do 95. Okay, predict. The stats score if college algebra was, let's do 95. So we'll take y equals 0.7 times 95 plus 26.7. I get 93.2. Here is a study that links memory with air quality index. So what they're going to do here is going to use AQI will be the independent or the X variable. Memory will be the Y variable. So I want to get an idea of if the relationship is even any good. So let's go back to Desmos with these numbers. As usual, I'll put in my X values first. I forgot to just down arrow, so I got to delete a bunch of things here. Okay, now let me go up and put in my Y values. And let me pull Desmos back. We got a good strong correlation coefficient. It's negative, so the data is decreasing as the X values get bigger. Y, my line is, I don't know if I'm going to round so much to negative 0.2. I think that's a little bit too much rounding. I'm going to go negative 0.25, negative 0.25x plus, and then I'll do 23.41. Now, predict AQI. That was the wrong question. I'm going to put in an AQI and I'll predict the memory number. Predict memory. For AQI equal to, I'm going to try to pick something a little beyond these numbers. So the highest number in here was 61. So let's do an AQI of 65. So Y will equal negative 0.25 times 65 plus 23.41. I get 7.16. So I'm guessing that's bad. And this completes the material for the course.